Hello, sir and ma'am. My name is Akshay Bajaj, and this is my project named as Shape Mover. And before we get into the project, I want to tell you something about myself. I am a robotics master student in University of Maryland College Park. Apart from that, I'm also a software developer in Cadeo groups, where I work on developing automation tools for data analysis and information extraction stuff. I also am a graduate research assistant right now in the mechanical department of University of Maryland itself, where I'm working on a really interesting project that is I'm working on developing a breast cancer detecting wearable, which I think can make a really difference in this life and in this world we live in. I Some of my interests are computer vision, machine learning, ROS, and like integrating all them together for some robotic applications. Apart from robotics, I also love UI design and blockchain. I love blockchain technology. So let's just get started into my project. So my project was basically to be a fun project, but also educational project. So for this, I use ROS Kinetic with the platform being the Turtlebot. Basically, I made a user interactive Turtlebot so that a user can give some input to the Turtlebot, and the Turtlebot comes up with a trajectory, and then the output would be the robot actually moving on the very same trajectory that he calculated himself to be in. So the importance of the project is that robotics should not just be about just the geeky stuff. I think it's more about being learning with fun, and that is what I'm trying to do here. So I think so. What my robot does is that it takes from the user the input, which would be the number of sites, and once the user gives number of sites, so the robot actually comes up with a calculation and trajectory and it moves in that particular shape. So for example, if you gave him 4 as the number of sides, so the robot will move in a square trajectory. If you give it 3, it will move in a triangular trajectory, and that is how my robot works. So it would be a really interactive way for the small kids to actually learn shapes. It would be in a very fun manner. For some older kids, I think it would be a really good medium of learning robotics, and also it would like create a lot of interest in them and in fields of robotics. When we think about the tinkering stuff, like the people who know nothing about robotics but want to know about it, so I think I want to keep this project completely open source, and because of that I think it would be a good start for them to actually work upon, because all of my code is as easy as I tried it to be and as descriptive as I tried it to be. So because of that they can actually be using like really important services and like subscribing odometer and TF, which I think is very important in most of the robotics projects that you can think of. So it would be a good fun experience without pressure, but also they'd be learning a lot. Now, the tools that I used for this, like for the simulators, would be Gazebo and Arvis, and the development process that I chose was solo iterative process along with test-driven development. And I'm using ROS on Linux and using Git, and the language I'll be using would be C++ with completely OOP concepts. Now, for the development cycle of the project, first of all, I ideated the project. That was all from blueprinting to project proposals and also coming up whether it's not in the uncanny valley or not. Then I conceptualized it, basically trying to make it into reality, coming up with product backlogs, defect logs, and everything, and also what ID should I use and what development process would it be. Then I actually start developed its methods, nodes, subscribers, basically writing the entire code. Once that was done, I actually came up with building and compiling the code that I wrote using CMake and Catkin make. So once that was done, then the part was debugging, which I took a lot of time in, and I think that was all worth it. Then I also unit tested and coverage tested it. For unit test, I use G-test and ROS test, and coverage test, I use coveralls. The integration testing was also done, and this is the delivery which I'm actually giving you, delivery of the product. So for internal architecture of the uh, code that we see. So it's basically, first of all, I thought in the old class diagram, you can see I just used two function definitions. One was initialize, another was shutdown. I was not planning on using odometry at all. All I was trying to think was just give it some trajectories that it could hard coding basically. But I actually changed my approach because it was not making the robot move exactly how I wanted it to be because of all the lags and everything and the dynamicity of the environment. So I actually am subscribing to now odometry messages and I'm publishing velocity message. And I also wrote every a different method for everything that I wanted it to do. For example, if I want the robot to go further, so I wrote the function move linear, which you can see in my class diagram. In this, there are parameters which are like number of sides which the robot is giving, the velocity by which the robot should move, and also the side length. And I also made a function known as rotate, which is the very same thing just for rotation, and the post callback that was for service call. And you can see there's always also a function known as circle, which is basically like if someone who is using the robot want to be a bit naughty and he's giving parameters or arguments such as less than 3, which would not make the robot make a bounded polygon. So it is just a dummy script which just makes the robot move straight so that my robot doesn't crash eventually. And yeah, move shape function basically calls move linear and rotate in a manner that the robot is able to move in the trajectory of the shape that he wants to. And we can look into the code further, but you can find my code in GitHub. um, when you see my activity diagram, so basically what I'm doing is I'm initializing all the nodes when you're starting it. Then I'm taking the number of side from the user. The moment the user gives the number of side, then I'm calculating the angle by 360 degree divided by number of sides, and also I'm using an exception handler for that so that no one gives 0, and as number of sides. And then I also start reading odometry readings of Turtlebot. Once I do that, I have the initial position of Turtlebot. Then I actually put both of them into the pro and I process the motion trajectory. Once I have the trajectory and robot knows where to move, so it starts moving. And I keep on asking the robot. It keeps on asking that whether the current position of the robot when it's moving is it equal to initial position, because once it is, so that means it got back to where it was and it can stop. Otherwise it will just keep on moving. And this is how my robot and algorithm works. So when you want to build my robot, so you can actually see that all you have to do is go in your Catkin workspace, do git clone my repository Catkin make, go back and just use, and now you have to use a command which will actually start my package. So first of all, you'll have to start Gazebo, Arvis, and service client that I'm using. So for that, all you have to do is just use this command known as ROS launch, toyrobot.launch, and all these three things will started. I will show you this in real time, but for some reason my video is not recording when I'm trying to do that. I'll actually add that video in the end so you can see that. Also, once you're done, now Gazebo, Arvis, and Service Client is launched. You can see all of them on your screen. So now you have to open new terminal to source level, because you just did a Catkin make, and you do this command as rosrun toyrobot and free space navigation node space number of side. Basically, if you want to make the robot to be moving in a pentagon, so just give 5 or give 3 for triangle, and so on and so forth. If you see this, so actually this was a video, but I'm gonna add a video of a live video of using my robot at the end, so you could just see how I'm actually building everything. So if you that was my project, and if you want to see the future scope and goals, so what I think of the future scope would be like to make it more interesting and add more shapes which are not just linear but also have arcs, and also like circular, have curves in them. Or I could also take more inputs from the user to make it more interactive, basically not just number of sides but also velocity and whatnot. And I also was thinking, why to just put it restricted to Turtlebot. We can also increase the spectrum of the project by extending it to multiple platforms such as Husky or Crazy Flies Quadrotor. That would be even better. And the last thing I was thinking was, just imagine, rather than one robot moving in a specified shape trajectory, wouldn't it be much more fun if we are actually able to move a swarm of robots to which could move in that particular shapes, or maybe swarm of quadrotors? That would be even better. So these are my future scope of this project, which I think I would be working on for sure, and I hope you like my project. And if you want to see the video of actually building it and how the project works, you can see it in the output file of my GitHub repository, or just stay tuned, it's just coming right after this video. Thank you. Have a great day.